Today's topic is just basically going to be about how we are using LLMs to automate our hacking tools and stuff out there. Basically, how hackers are leveraging on these LLMs to
Mm.
go and do their offensive stuff. Let's say the offensive stuff because defensive is in the corner. So I would like to Okay, I would like to say and make this known that this is part of the NESTCON journey. We're all trying to start from now before we crown the whole thing in somewhere September or October for the event to come up. So, Ryan, can you break down this for us? Just LM powered autonomous hackers like the Defender, Darktrace. What makes the difference?
Okay, so when we talk about LLM or large language model autonomous hackers, we are basically referring to large language model or AI-driven systems that can essentially reason through objectives, right? Break down into steps and use tools, decide what to do, you know, with very little to no human output in order to achieve, uh, or in order to achieve a certain goal. Yeah. So basically, that's what we refer to as large language model or language model powered autonomous hackers.
Okay, thank you, Ryan. Well, that explains some particular stuff because sometimes people try to confuse it between the tools that we have that we've incorporated some AIs into it and all those kind of things. So
Okay.
thanks for
Right,
clearing the
right, right.
difference for us.
Yeah, and let me say that like the traditional automated security tools, right? They are normally rule-based, right? Or workflow-based. They have patterns that you follow in order to, produce an output. So, for example, a scanner will check for known weaknesses, produce findings, and you, the human being, will now have to interpret them, search for fixes and stuff for that. But for LM or large language model powered agents, right, it's different because they are operating as the hacker, right? The traditional tools operate as just that, a tool. You still remain the hacker, in charge of interpreting to results and whatnot. But for a large language powered agent, right, they assume the role of the hacker and they operate more autonomously than you using a simple tool or an automated scanner. So they can read documentation, they can understand context, they can connect clues, prioritize paths. I mean, we'll see an example shortly of how a typical large language model powered hacker or LLM uh, autonomous hacker, can, you know, perform a simple penetration test, right? I'll show you a brief glance on that for you to see how um, that's done. So basically, the key difference here I'll say is adaptability, right? So existing uh, automation tools or existing tools automate tasks, right? That would rather take a long time to do manually. But agents or hacking agents can they take charge of some of the decision making process in order to achieve a goal. So they use the tools. Some of these autonomous hacking agents even use uh, automated cybersecurity tools as part of their tool sets to, perform uh, these attacks or tests against systems.
So yeah, thanks for explaining that into details for us. The next a set of questions I would like to ask you in regards to this topic is from the red team angle. So let's look at it from an offensive person perspective. How are red teamers actually leveraging the LLMs to carry out attacks? And what does it change about how we operate or how they operate in the industry?
Okay, so for that, I would like to, show you a practical example of a tool that is being used to automate penetration test. I'll sh- uh, if you allow me to share my screen, I'll show you that.
All right. Please go
Yeah.
ahead.
So, okay. So those of you here, I mean, you can try the tool out yourself. It's called Strix, and it's pretty easy to set up, right? It's very easy to test. Okay, so you know. Back to our first question, when we spoke about open source AI hackers, this is a very typical example of one. It's, I think, one of the highest rated AI autonomous hackers that we have out there. It sits at 25 stars on GitHub. It's pretty easy to set up with your LLM key and whatnot, right? So normally with a pen test, before you start a pen test, you have to do your passive recon, active recon before start your test and do all of that. But this does everything from start to finish, right? It helps you do everything from start to finish. So instead of talking about, how it changes the the scene in the red team space, I think I'll go ahead and show you. Can you see my terminal?
Yes.
Yeah, good. So this is we are going to start performing a test against this site at Krakow, right? Edin Krakow is a test site that we built for training. So it's not and I like to state categorically that please do not use this tool on um websites or web applications you are not allowed to test. This is our training web application, so uh, I'm allowed to test it. So as you can see, I started, doing something. It's just as easy as doing this, right? Just streaks, target, then you state your target name. But since we've already started with it, I'm going to just resume it. So as you can see, the barrier, one thing before you even continue is that it's now, kind of more or less like reducing the barrier to entry sort of, right? That you don't need to be a pro. I mean, you need to be a pro so that you understand what you're doing, but this to anyone, beginner or not, can pick it up and spin it up anytime, anywhere. So that's one thing that is affecting the space. So we are just going to resume this to see how it works. But one thing about it is that this is also quite costly in terms of API cost. But with cheaper models like DeepSeek, you should be able to run this for much cheaper. So as you can see, starting. So as you can see, it says recon is underway. I'm pausing for the first concrete result. So it's waiting for recon and mapping agents to return to initial findings on the website. So as you can see from the beginning, remember what I mentioned earlier when we started the call? We spoke about goals, right? A bunch of agents working together to achieve a goal. This is a typical example of what it's doing. So it's the agent has autonomously assumed the role of the penetration tester or the hacker, and it has created a to-do list. Normally, you, the cybersecurity professional, would have to sit down, create a to-do list, then select the tools to use, what you do first, what you do that, and then you use the automated tools, right? Or the automated tools to manually automate those tasks. But right now, this is just doing everything. As you can see, it is crossing out things in real time, right? So it is updating its to-do list as it's performing the test and whatnot. So you see, it's doing that right now. It's now you remember I mentioned earlier about uh external recall. You have to sit down, do all of that manually. Over here, you can see that it's doing the external recon on its own. I didn't have to think about that to tell it. all I just did was specify the target and it's doing everything from, but then again, it's expensive, right? As you can see, my token cost here, it runs up like crazy. So probably by the end of this pen test, if you are to perform a full assessment on this black box, it should cost you about $15 using GPT 5.4, right? It should cost you roughly around $15. Yeah. So yeah, this is a typical example of the um how agents or autonomous hackers are revolutionizing the red team space, especially when it comes to web application assessments.
Okay. Well, that looks interesting and scary at the same time because sometimes you look at these things and people just out there pick it up and they are doing the work for you. So imagine
Yeah,
someone who
yeah.
sat down to learn the skill manually becomes kind of like,
Mhm.
okay, things are just going
Well,
wild there.
yeah, well, you're right. But then again, the room for technical expertise will always still be there. Because right
Yeah.
after exam, you still have to validate, right?
Mm-hmm.
Even though it performs validation, but you still have to write a report. Well, it will write the report for you, but you still have to edit the report. You have to understand you have to be able to understand what it's doing to be able to then again interpret it to a client. But then again, it can interpret it to a client.
Yeah.
But yeah, but
Well,
at the end of the day, there'll always be the need for a professional to be behind these.
yeah, there's always
Yeah,
a human factor needed. So you
exactly,
always have
exactly.
to check through, okay, that everything you're doing is as expected. Well,
Yeah,
then
yeah,
it should just be comforting enough if we look at the blue team side. How are we using this
right.
tool at the blue team side if you're looking at the offensive side? So that brings us to our next question. If attackers are using LLMs to move faster and smarter, how are blue
Mhm.
teamers using the same technologies to detect, respond, and stay ahead of them? Because we always have to stay ahead. It's a cat and dog fight.
Right,
We are always hitting each
right,
other.
right, right. Awesome. So then again, I would have to show you in a practical sense again. As for
Okay.
me, I'm Mr. Practical, so I don't like to just talk to. I like to show you practical solutions, right? I believe in practical solutions to uh, enlighten anyone listening or watching this. So let's go to this. Give me a moment. Yeah. So can you see my screen?
Yes.
Right. So I'm sure you are familiar with Wazoo, right? Or Waza,
Yes.
the scheme for, yeah. So as a as attackers are quickly adapting to using these AIs or large language models or agents for hacking, testing, and red teaming and stuff like that. As you mentioned earlier, on the blue team side, now they need to be quicker in both detecting, triaging, and responding to these incidents, right? And in order to be faster, AI, you can easily connect your SIEM, right? In this case, which is um, Wazoo or Waza to an AI security analyst that can answer your questions in natural language and can interpret what's going on in your environment for a junior SOC analyst to easily understand. Now, as we are reducing the barrier to entry for the attackers, it must be the same for the defenders too, so that you can match, you know, the attack to the response. So this is connected to Wazoo, right? It's a test environment again that we can easily ask a question like what so like let's say I'm a security analyst, right? Right, I can easily come here and I know you work in security operations, right? So you would you know firsthand how difficult it is like dealing with a lot of logs, right? A
Yes.
lot of people
Quite,
coming in triaging,
quite
knowing what
overwhelming.
exactly gets very overwhelming. Now, what if you can ask these questions in natural language to your scene, right? So you can easily ask it, what are the latest alerts? What are the latest high severity alerts for today? So we are just asking it in natural language. We don't even have to go and look at our Wazoo dashboard, right? We can just ask our agent here in natural language, and our agent is going to be the SOC analyst to go and view those alerts and analyze it for us and give us something comprehensive. So let's see what's going to do for us here. So as the analyst, you can just sit down, make your cup of coffee and get your bottle of water whilst you eat. So I mean, like just put this in your shoes, right? You having this where you work, where you can just turn up for your shift and be like, what happened last shift, right? You can just ask it to the large language model and just sit back, right? And watch it do its thing. So let's watch it um, perform two calls and get, you know, yeah. So it's going to get all of that what we need. And this is just a one-line question. You can prompt it better to get more information on what you want, but just the bare minimum, right? A one-line question. Let's see what we get from that. So already it's telling you that you have high severity. There's a significant volume of high severity alerts, but let's to realize it's doing its two calls, calling tools, doing all these things autonomously. Back to the first question point again, where it's doing all these things autonomously, getting the agents, calling what tools, filtering alerts, it's doing all of that on its own. Now you don't have to do that. So let's see what's able to get. While we wait. So as you see, it's being autonomous. You see, I see there's more to this than just brute force. There's active PowerShell too. Wow, let's go. Let's go. Nice. So incident one, so it's breaking down into incident, telling you the attacker IP, target account, alt protocol. Incident two, level 12 is telling you what it is. Level 9, giving you a threat correlation map, telling you what is going on, right? It's even telling the country that the brute force is coming from. Now, all of this, I've not opened the my Wazoo or anything to do all of this, right? Now it's giving you recommended next step, block the attacker IP, investigate partial activity. So let's ask another question. Do we have any level 14 or 15 alerts? Just to be more thorough to ensure that we don't have, any high level or more high level alerts to do. So it's going to check directly for those severity alerts. You're going to filter down on those severity. And yes, it does. So it's pulling the details for that. So Bernice, I mean, you can go ahead and tell me how useful would this be for you as a security operations analyst or someone working in a SOC?
Well, it looks very interesting because, honestly speaking, if you are to investigate, or maybe from the last shift, the high alert that came through, you'll be using a lot
Mhm.
of solutions in here because sometimes you open a particular solution, you look at an alert, and it's referencing something else in another solution. You need to go
Mhm.
down, drill into them one by one, just to be sure that whatever you are seeing is what is been happening in this solution, just to cross check. But with the
Mhm.
AI prompt here, it looks like it's pulling everything from every source into one.
Exactly.
Then it gives
Mhm.
you a detail of what is going on, how, when, where, like every timeline and summary, or not even a summary, an overview of what is happening
Exactly.
in the alert,
Yeah,
and giving you a detailed information of what to do. So it makes it quite interesting that it reduces the time. Sometimes at the
exactly.
source gets alert fatigue because of the a lot of things
Exactly.
that goes
Mhm.
on. So this reduces. that
Yeah.
alert fatigue and kind of like take care of it in a particular way that you should be fine at the end of the day as a SOC analyst. Work doesn't look like
Exactly.
you're going crazy in the SOC. Things are just
Exactly. Yeah.
getting
Yeah.
overwhelming.
Perfect, perfect. So yeah, now I don't have to go and speak a lot of English and rattle out what or how is going to benefit this, or how the blue team angle is going to benefit from this, because you are like a typical example. Now you've seen how now even at the end of the day, if you want to write a report, you can just ask it, write a comprehensive end of the report for me. After we can tackle isolation. So you just have a conversation with it like you are talking to a junior analyst. So AI, what these AI agents are doing is that it's now putting you in charge. Now it's now making you the manager to focus on the high level decisions, right? Now you are taking the high level decisions and it's doing all the low level work.
Okay, that's interesting.
Yeah.
Well, as the report is generating, I would like to loop in one particular question because we talk about the high level managers. We need
Mhm.
this AI in some certain environment. So that will bring
Mhm.
us to our last question for the talk show so that we loop everything into one and just reference. So, Ryan, beyond the security teams, both offensive and defensive, how can an organization actually enable or even embed LLM powered tools into the broader operations to genuinely strengthen their security posture, not just a trend, but as a real strategy in our environment?
Okay, so first of all, we would have to look at AI integration, right? We would have to know how to we organizations need to first understand their infrastructure. What are they using now? Like what do they have access to? You need to know what you have in your environment. Now you have to slowly adopt AI, right? Where you don't just get up and put all your information into a large language model and I sorry, I kind of lost I kind of lost my train of thought here, but yeah, what I'm trying to say is organizations first need to understand what they have in their infrastructure, know what already exists, right? And look into AI integration measures that properly understands the context of their infrastructure whilst keeping their data private. So one thing that I would like to talk about would be using local models or models that run on edge, right? You also need to
Okay.
look at the issue of cost. If you want to use cloud models, right now, OpenAI they have Azure plans where your data is confined to your cloud instance. So even though you are using API keys from OpenAI, your data doesn't go to OpenAI's infrastructure. You're able to keep that in-house. But for those who really, really want to keep it in-house and not pay for token costs at all, then you can look into um, local models, right? Training AI security models that run locally on site, right? Then you don't have to deal
Okay.
with cloud bills or anything. They work with or without internet connection. And I think that's even better in a security setting because what will you do if your internet is cut off, right? You need to be able to, you need an AI that is reliable no matter what. And these days, it's training or fine-tuning large language models for security is something that is being done day in, day out. Another thing you also need to look at is the governance side of things for large language models. I will show you one shortly where something that I use to manage my or a tool that I use for AI governance. Let me quickly log in. Let me show you that. So with the AI governance, you need to know what your organization is feeding to the AI. You need to know the type of outputs your AI is giving. You need to be aware of the prompts that the people working for you are feeding to the AI, the type of information that they are feeding to the large language model. There has to be detailed record of all of that. You need to be able to track how your agent performs over time, which is all part of AI governance. I would show you a lot of people I see talk about AI governance theoretically. I'm yet to see someone discuss AI governance in practice, especially here in Ghana. But as I said, I'm a very practical type of person, so I would show you an example. Just give me a moment to pull this up. Okay. So as you can see, for every agent that I deploy, I have the names here. Whatever, if anyone is having a conversation with my agent, I'm able to see that there's a record of all my conversations or every single conversation that has been had with my agent, right? I can see the traces for the period, who said what. So with this, you could see that someone was trying some prompt injection and all. I can see everything from here, right? People trying. So if there's an issue, I can easily pull it out and submit to auditors or whatsoever, right? This is very, very important when deploying AI to a production environment. You need to be able to trace what the AI said at what time, what it did at this time, what it did not do, and what not. Because at the end of the day, you need to keep, so far as you keep humans, is the human you are keeping accountable. Because at the end of the day, like we don't hire AI, we hire humans, right? So if you are using a large language model, there has to be that layer of accountability, right? So if someone is having a dangerous conversation with it, if it's using tools it's not supposed to use for a certain conversation, I can see that over here, right? So yeah, basically AI governance, knowing how to track your cost and all, is it's essentially some of the ways that companies or industries can adopt AI, but the governance is the most important part, if you ask me. Yeah.
Okay, thank you, Ryan. Well, maybe I didn't make it known to the people who join us today. This is something we are doing within just a short period, maybe 30 minutes, 20 minutes. So today is not a full session, but I would like to give 5 minutes to anybody who is on the call. If you have any question aside what we discussed already, and Ryan could also try to answer within the short 5 minutes, then we close today's talk on that. But I've really had interesting session with this because when it comes to AI, it's never stopping, it's never going on a pause or anything. It's just going to be advancing and everything and all that kind of thing. So please, you have any question? Phoenix, Links, Blake, anybody on the call, do you have a question for Ryan aside what we discussed? Okay. Ryan, thank you very much for having us today and sharing your information with us. That was very insightful. Unfortunately, we'll have to end the discussion here today and maybe for another time, maybe loop over the topic again and go into detail on a different session. Thank you very much. And everyone, have a nice evening and thanks for joining. Phoenix, Links, Blake, thanks for joining us. Yes. Have a nice evening, everyone. Bye.